Okay, hi guys. So in this lecture, we'll be discussing on abnormal Reimer-Tieman reaction. Okay, so in the previous lecture, we discussed the mechanism of the Reimer-Tieman reaction, and in this lecture, we'll be seeing a slight difference in the normal Reimer-Tieman reactions mechanism. Okay, so suppose we have something like this. Okay, and we are reacting it with again chloroform in presence of a basic medium. We are heating it, and to a surprise, we see a benzene or a chlorobenzene rather, okay, as the product. So how does this take place behind the scenes? So we'll be talking about that. So suppose in this we actually pass the basic medium, what will happen is this OH minus will actually attack on this H plus and will get negative charge here, and similarly these two will actually again react it between themselves and will form a carbene, right? So this negative charge will actually attack on this carbene, so we would get something like this compound, or rather actually we did discuss the formation of carbene and the reaction of cyclohexene ring after it. So the negative charge won't be attacking on the carbene, we'll be getting a 3-member ring when this double bond actually attacks on this carbene. So we'll have negative charge here, and so no negative charge. Okay, so next what will happen is we have H atom also here. What will happen is this bond will come in contact with this carbon atom, they will form a double bond here. Next what will happen is this bond will break up, okay, creating a double bond between this carbon atom and this carbon atom, okay, and at the same time one of the two chlorine molecules would be detaching itself from the carbon atom. So we'll get something like double bond here. This carbon atom I am marking here have a single bond, okay. This carbon atom I am marking here, they also have a double bond, and this carbon atom and this carbon atom, which are those two, also have a double bond, and we have a chlorine attached on this carbon atom. So we can see that benzene ring is formed with chloro group attached, hence this is the product. Okay, so let us take some examples on the same concept. So we have something like this, where we have this compound and we have CHBr3 in presence of tertiary butoxide or other tertiary butanol, and we are hitting it. What would be the product formed in this case? Again, the tertiary butanol will act as a good base, okay. Obviously it's a very bad nucleophile, but it's a good base, okay. I hope you remember the difference between a nucleophile and a base. In nucleophile we just don't, in nucleophilicity we see the basicity as well as the steric hindrance, but in basicity we just see the electron rich compounds, okay. So it will take on the H plus, creating, and at the same time when C minus Br 3R is created, one Br would be leaving, and it will result in the formation of a carbene, where we'll have something like this structure, okay. Now this was the first step. What happens in the second step? In the second step we have something like this will be attacked on by again the base or the tertiary butanol, and we'll get something like negative charge here. Again on carbene, we have seen so many times when we were discussing the reaction and preparation of carbenes, that the cyclohexene ring actually attacked on the carbene, hence formed and formed a what is called a 3-member ring with the carbon atom of the carbene molecule. We'll have something like this and negative charge here. Again this H atom, the bond would be taken back, and these two carbon atoms would be forming or indulging in a double bond. Similarly this bond will be breaking up and will be creating a double bond between this carbon atom and this carbon atom, and at the last this Br2 group, one of the Br2 group would be leaving this carbon atom, okay, as a Br minus. So as a result, we will be getting something like a bromobenzene. Okay, let's see another example. We have something like, so we have something like again pentane ring with two alternate double bonds, or rather two double bonds. Okay, so we'll have something like this is structure. Okay, okay, and on this we are reacting it with CH, CHFCl Br. Okay, and in presence of obviously a good this time obviously a base. Okay, so what will happen in this reaction is, obviously we'll be getting this F minus will be actually attacking on this carbon atom, or rather the hydrogen atom attached to the carbon atom, and which of the following groups will be moving? The Br minus would be moving, because if it's the best leaving group, because Br minus is the most stable among Cl minus and F minus, hence we will get a carbene like this, F and Cl here, and this carbene would actually okay, so F and Li would actually also be attacking on this hydrogen atom, which is attached to the cyclobutyl with two double bonds ring, and we'll get something like a negative charge here, and this negative charge will then, by the formation of this negative charge, this double bond would be actually acting on or attacking on this carbon atom in the carbene ring, and at the same time will be forming a something structure similar to this. Okay, negative charge here, and we'll have a hydrogen atom also here. The hydrogen atom would be breaking itself from the carbon atom, forming a double bond between this carbon atom and this carbon atom. At the same time, this bond will be getting broken and would be formed as a double bond between this carbon atom and this carbon atom and this carbon atom. At the same time, from the F and Cl minus is obviously a good leaving group, and Cl minus would be leaving the compound, and as a result the final product we would be getting is a fluorobenzene. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples of Reimer-Tieman reactions, and then we'll be starting off a new topic called isocyanate test or carbylamine reaction. So with this, good luck and goodbye.